In the vast expanse of space, far beyond the comforting warmth of our sun, two resilient pioneers continue their journey through the cosmic unknown. Launched over 40 years ago, Voyager 1 and Voyager 2 have traveled farther than any human-made object in history, entering regions of space that no one has ever explored. These spacecraft, equipped with technology that now seems almost primitive, have defied all expectations, not only by surviving the harshness of space, but by continually sending back data that challenges our understanding of the universe. Voyager 1 launched on September 5, 1977, and Voyager 2, launched just 16 days earlier on August 20, 1977, were designed to study the outer planets of our solar system: Jupiter, Saturn, Uranus, and Neptune. But as they ventured beyond their initial missions, they began an unprecedented odyssey into the vast unknown, becoming our first interstellar ambassadors. The story of these spacecraft begins not in the cold vacuum of space, but on Earth, in the minds of visionary scientists at NASA's Jet Propulsion Laboratory, JPL. Among them was a young engineer named Gary Flandreau. In 1965, Flandreau made a remarkable discovery that would change the course of space exploration forever. He realized that a rare alignment of the outer planets, occurring once every 176 years, would allow a spacecraft to visit all four gas giants using a technique called gravitational assist. This technique would allow a spacecraft to use the gravity of each planet to slingshot to the next, reducing the time required to reach Neptune from 30 years to just 12. NASA knew they had to act quickly to take advantage of this once-in-a-lifetime opportunity. Thus, the Voyager missions were conceived with the primary objective of exploring the outer planets. However, no one could have predicted the incredible journey that lay ahead for these two spacecraft. As the Voyagers embarked on their grand tour of the solar system, they began sending back data that would reshape our understanding of the cosmos. They revealed the complex and dynamic worlds of the gas giants and their moons, uncovering phenomena that were previously unimaginable. For instance, Voyager 1's encounter with Jupiter in 1979 revealed a world more active and vibrant than anyone had expected. Its cameras captured stunning images of Jupiter's Great Red Spot, a massive storm 3 times the size of Earth that has raged for centuries. But the real surprise came when Voyager 1 sent back images of Io, one of Jupiter's moons. Io turned out to be the most volcanically active body in the solar system, with eruptions so powerful they could be seen from space. These discoveries didn't stop with Jupiter. As Voyager 1 moved on to Saturn, it continued to astound scientists. In 1980, it sent back detailed images of Saturn's rings, revealing their intricate structure and dynamics. The spacecraft also studied Saturn's largest moon, Titan, which was found to have a thick atmosphere rich in organic molecules, hinting at the possibility of complex chemistry similar to that which might have existed on the early Earth. Meanwhile, Voyager 2 was forging its own path through the solar system. After its encounters with Jupiter and Saturn, Voyager 2 became the first and only spacecraft to visit Uranus and Neptune. In 1986, it flew past Uranus, discovering 10 new moons and capturing the first close-up images of the planet's tilted magnetic field and faint ring system. 3 years later, in 1989, Voyager 2 reached Neptune, where it uncovered unexpected details about the planet and its largest moon, Triton. Neptune's atmosphere, it turned out, was home to the fastest winds in the solar system, reaching speeds of up to 1,200 miles per hour. Triton, with its active geysers and surface temperatures colder than any other known object in the solar system, became a focal point of scientific interest. With their primary missions complete, the Voyagers could have ended their journeys, but their instruments were still functioning, and NASA saw an opportunity to push the boundaries of exploration even further. The mission was extended, and the Voyagers were directed to continue their journey outward, beyond the influence of the sun's gravity and into the interstellar medium, the space between the stars. As the Voyagers moved farther from the sun, they began to encounter the boundary of the heliosphere, the vast bubble of charged particles and magnetic fields that surrounds our solar system. This boundary, known as the heliopause, marks the point where the solar wind, a stream of charged particles flowing from the sun, slows down and is eventually overtaken by the interstellar medium. For decades, scientists had theorized about the existence of this boundary, but no spacecraft had ever crossed it, until Voyager 1. On August 25, 2012, Voyager 1 made history by becoming the first human-made object to enter interstellar space. As it crossed the heliopause, Voyager 1 detected a dramatic increase in cosmic rays, high-energy particles that originate outside our solar system. This was the moment scientists had been waiting for, a confirmation that Voyager 1 had left the protective bubble of the sun's influence and entered a new realm of exploration. But even as Voyager 1 ventured into interstellar space, it continued to send back data that puzzled scientists. For instance, the spacecraft detected no significant change in the direction of the magnetic field as it crossed the heliopause, contrary to what was expected. This finding has led to ongoing debates among scientists about the true nature of the boundary between our solar system and interstellar space. Meanwhile, Voyager 2 was still making its way towards the heliopause. On November 5, 2018, it too crossed this boundary, entering interstellar space and providing a second set of measurements that confirmed and expanded upon the findings of Voyager 1. However, Voyager 2's data added another layer of complexity to the mystery of the heliopause. Unlike Voyager 1, Voyager 2 did detect a change in the magnetic field direction, suggesting that the structure of the heliosphere might be more complex than previously thought. These unexpected findings have sparked new interest in the study of the heliosphere in the interstellar medium. Scientists now believe that the heliosphere might not be a simple, smooth bubble, but rather a more complex and dynamic structure, shaped by the interactions between the solar wind and the interstellar medium. The Voyagers have provided us with our first glimpse of this boundary, but much remains to be understood. As the Voyagers continue their journey through interstellar space, they face new challenges. Their power sources, which rely on the radioactive decay of plutonium-238, are gradually weakening. Each year, the spacecraft lose about 4 watts of power, and NASA has had to make difficult decisions about which instruments to keep running. Despite these challenges, the Voyagers are expected to continue sending back data until at least 2030, at which point their power will likely be too low to operate any instruments. Even as their power diminishes, the Voyagers' legacy is secure. These spacecraft have not only expanded our knowledge of the outer planets and the boundary of our solar system, but they have also carried with them a message from Earth, a message intended for any intelligent beings that might one day encounter them. Attached to each Voyager is a golden record, a time capsule containing sounds and images from Earth, including greetings in 55 languages, music from around the world, and images of our planet and its inhabitants. This golden record, curated by a team led by renowned astronomer Carl Sagan, is a testament to the optimism and curiosity that drives human exploration. It represents a hope that, even in the distant future, long after the Voyagers have stopped transmitting, they will continue to carry a piece of humanity into the cosmos. In the meantime, the Voyagers continue their journey, moving ever farther from Earth. Voyager 1 is now more than 14 billion miles away, and Voyager 2 is not far behind. They are traveling at speeds of over 35,000 miles per hour, but even at these incredible speeds, it will take them thousands of years to reach the nearest stars. In about 40,000 years, Voyager 1 will pass within 1.6 light-years of the star Gliese 445, currently in the constellation Camelopardalis. Voyager 2, on the other hand, is on a course that will bring it within 1.7 light-years of the star Ross 248 in about the same time. After these encounters, the Voyagers will continue to orbit the center of the Milky Way galaxy, destined to travel through the stars for millions, perhaps even billions of years. The story of the Voyagers is one of human ingenuity, perseverance, and the unyielding desire to explore the unknown. These spacecraft, designed for a mission of only a few years, have exceeded all expectations, becoming symbols of humanity's quest to understand the universe. They have shown us that, with vision and determination, we can reach beyond the boundaries of our world and explore the farthest reaches of the cosmos. As we look to the future, the lessons learned from the Voyager missions will continue to inspire new generations of scientists and explorers. The data they have sent back will be studied for decades to come, providing insights into the nature of our solar system and the interstellar medium. And as we develop new technologies and embark on new missions, the spirit of the Voyager missions will guide us as we continue to explore the unknown. In the end, the Voyagers are not just spacecraft, they are emissaries of Earth, carrying our hopes, our dreams, and our message to the stars. Their journey is a testament to the power of human curiosity and the enduring quest to understand our place in the universe. And as they continue their silent voyage through the cosmos, they remind us that the spirit of exploration knows no bounds. The story of Voyager 1 and Voyager 2 is far from over. As they continue to travel through interstellar space, they will keep sending back data, challenging our understanding, and opening new windows into the mysteries of the universe. Their journey may eventually come to an end, but their legacy will live on, inspiring future generations to look to the stars and ask, "What's out there?" For now, we wait with anticipation for the next signal from the Voyagers, knowing that each transmission brings us closer to answering the fundamental questions about our place in the cosmos. And as we listen to the faint whispers from these distant spacecraft, we are reminded that in the vastness of space, we are all explorers, embarking on a journey that has only just begun.